everyone. Welcome to today's session on Introduction to LLMs and Fine Tuning. I'm Ankita and I'll be your moderator today. I represent SpringPeople, India's leading enterprise training provider, and I'm so glad you could join us. In this session, we'll explore the basics of large language models, look at some common use cases, and talk about how fine tuning works. The idea is to help you see how fine tuning can improve accuracy, align models with business needs, and bring real value in practice. We are also very excited to have a special guest with us today, Mr. Rajiv Chandran. Mr. Chandran is a highly respected technology leader with close to 2 decades of experience. He has an incredible track record of bringing together products, data science, engineering, and software to build large scale, high performance solutions used around the world. His expertise spans data engineering, machine learning engineering, data science microservices, search, cloud, and DevOps. He has worked across e commerce, retail, search, and advertising, leaving a lasting impact in each. It is an absolute privilege to have him with us today to share his experience and vision for the future of technology. With that, let's get started. Mr. Chandran, the floor is yours.
Thank you, Ankita. Hope my audio is clear. Extending a warm welcome to all of you all for this session. It's actually specifically focused on fine-tuning your LLMs, expecting that you have a understanding of LLMs otherwise in terms of its use and things like that. So let's get started and let's understand a life cycle of an LLM. So LLM's life cycle begins with its creation, and we call this activity pre-training. And to get this going, we collect a lot of data, clean up the data, and then we put it into a process. This is nothing but a neural network that we put into, and the outcome of that process, the outcome of that, the product, I should say, is what we called a pre-trained LLM. Now, pre-trained LLM, though good, it is very generic, and you may not be able to use for all of the use cases that it may be needed. Another way is we could actually build a pre-trained model that is very specific to your domain, but that's a very costly exercise. And otherwise also, though pre-trained may not be very specific to your domain, it still has a lot of generic data that would help your specific domain as well. Hence, we get into this idea of fine-tuning. It's adapting your pre-trained model to very specific tasks or domain that you want to use it. So we have a pre-trained side of it, fine-tuning, and then once that is done, we deploy it into your production to use it in the way you want to kind of use it. So this is generally the life cycle of an LLM, and the analogy goes saying that you have taught somebody English language, in which is what we call a pre-training exercise, and from that we are fine-tuning that speaker to become very specific in terms of a lawyer or a doctor, in terms of its language adaptation, and then once it is ready, you are actually deploying it for a usage. Okay. So this generally are these 3 steps that involve in your LLM's life cycle. Okay, so what is fine-tuning then? So fine-tuning, as I just mentioned, is the process of taking any specific trained model and adapting to your specific domain. And the whole objective here is that we want to have a very specific model while still retaining a lot of generality as well, because it helps overall being a bit general as well. And as I told you, the analogy, it's pretty much taking an English language, uh, you know, I mean, teaching English language to a student, and then once the student learns English language, we are specifically fine tuning his or her skills to uh, the language which is probably in the legal domain or in the medical domain, so that those specific jargons you understand, and you understand the meaning of it, which otherwise you wouldn't know. However, we must understand that this specific process is still built under the larger overview of the specific English language. Okay, so now why fine tune? So this is something that everybody asks the question: why do you really want to fine tune? And so there are one is, of course, the domain adaptation itself. Uh, Now the other very important aspect of fine tuning is to make it task specific. Like when I say task specific here, will it adapt for code generation? Uh, and in code generation, will it adapt for a specific code generation? Like, is it specific for a Python or a Java or a C, C++, etc. Or is it adapt in a summarization or a classification task? So it is just not about domain generation, domain adaptation itself. It's also about very task specific optimization that you want to go through. And now, another very important requirement. When you are going to adapt an LLM, say a very classic case for a legal requirement, you take any model, and let's say you want to create a very common thing which many of us may be doing, a rental agreement that you want to create it out of an LLM. Now you may not be able to probably go to ChatGPT and create a rental agreement. In the sense, you can create it, but it becomes very generic. It would never be adapted to an Indian environment or to a very state specific requirement. So you want your LLMs to be adapted to that kind of a requirement. So this way it becomes very targeted. And then LLMs generally are very I mean it's very a costly affair overall to build it, to host it, and consume it as well. It's overall a very compute intensive exercise. That means there is quite a large amount of cost associated with any activity that you do. So the more you fine tune, you can get you can make it more cost effective. When I say fine tune in this case, what happens is it's about not I mean, I should put it this way: larger the size of the model, the more accurate the results are. So the larger the size, but you also increase the cost of operating it. So if you could take smaller models and fine tune that, so the overall cost effectiveness comes down. The cost operating cost comes down. So for that also we fine tune so that we avoid using larger models for very specific use cases. Like as I said, if you want to use that in a medical or or anything related with law, we would want to take smaller models and add the data to it. So that way it becomes better. And you also want it to be with your human preferences. In the sense, you do not want harmful content to be generated. You want that to be as as clean as possible in terms of the data that is being generated. So that way, any toxicity that is associated with the models are kind of models generally are toxic in the sense when it comes out pre-trained, there is always a level of toxicity that is associated because you are not specifically mm, uh, specifically removing a lot of content because the cost associated with that to make it or rather in the process of making it generic, these toxicity gets added to it. So that way you would also want to have it aligned. That's why we do a pre-training. So every model whatever is built goes through some level of pre-training. It's kind of any product coming out of a manufacturing stuff goes through some level of fine-tuning in either way. It's very specific to that. Okay, now that we know we need to fine-tune, so let's look at what are the possible ways of having possible ways of fine-tuning it. So there is this idea of instruction kind of tuning. There are domain adaptation fine-tuning. There is this partial fine-tuning and reinforcement learning with the human feedback kind of fine. These are different ways. These are different strategies of fine-tuning. So if you look at it, if you take this instruction and we look at these examples, we'll look at analogies to give you very simple understanding of this. So if you look at the instruction tuning, it is low cost, but the gains are not very effective. And if you take this domain adaptation fine-tuning, it's with moderate cost and there are of course moderate benefits. It sometimes be more than moderate if you actually look at it. And when you do partial fine-tuning, there are benefits. There are higher benefits at moderate cost gain. So this is what people today target. Okay, and then there is this human, the reinforcement learning with human feedback, where the benefits are high, but the cost is even more. So kind of a chart showing about all these different kinds of ways of strategies of fine tuning. And we look at now from an analogy perspective what each of these means at this time. So now if you take a case of an instruction tuning, which is low cost, low moderate benefit, a classic use case is about, like, say, if you want to build a summarization perspective, this is a use case, or we want to do a convert a text to JSON. So these are a very specific use cases of instruction fine-tuning, and you're making it very, very specific here, and getting these done are not very complex. And of course, domain adaptation, you are pretty much aware. You can take any of the models, and you want to improve that. Say in this classic case of biomedical Q&A, entity recognition, or some summarization, or any legal or any other process domains that you may want to kind of take. So we would take there and adapt it. So this is that's the idea of domain adaptation. Then there is PET, parameter efficient fine-tuning. Now this is a very classic case of domain adapt chatbots running on single loop without retraining billions of weights. Okay. Now what this it does is it pretty much does domain adaptation. It is doing a domain fine-tuning, but with a very low cost and high benefit. So previously you saw that doing otherwise general domain adaptation is a moderate gain and moderate cost. So it was not giving you that efficiency, but going through this process gives you really high value outputs. And then, of course, reinforcement learning is a very classic use case is how to make it safer, less toxic responses, more helpful outputs, etc. So these are the different strategies that you want to adopt while doing your fine tuning. Okay. Now let's take a very simple example, but which I'm sure everybody is aware of, bidirectional encoder representation transformer. It's a transformer. It is the first tool that came out of after the neural way of embedding text came out through word to word. And it is still used very popularly. And why we talk extensively about BERT, it's largely because of its cost effectiveness, contrary to using tools like the GPT equivalent LLMs. BERT is not GPT, by the way. GPT is, it does much more than what BERT does. And BERT is very good at summarization and understanding, etc. While GPT, which is again, it's an architectural change, which has both encoder and decoder, and this goes by largely encoder. So there is the ways of designing it. So this, if you take and you want to fine tune, what we are actually looking at is here. There are, as you were aware of, neural networks have multiple layers. They are built with multiple layers. There's an input, there's an output, and there are multiple hidden layers. So in fine tuning, what you do is you freeze many of these hidden layers, and then open up for training only the last few layers. So that way, you don't have to do this idea of full training, which is equivalent to do your own model as it is, right? So that's the intent, right? So if you go for full training, then you will have to kind of work with those 100 million parameters, what BERT does. So now when you do a fine tuning, or which we call as a partial fine tuning, then all that we have to do is worry about pre-training, training maybe a 10 or 20% or 30% of the layers within the model. So that way we gain through lesser effort with a maximum output. And this table kind of summarize, if you are doing full training, all the parameters are used, it's high, and of course the storage size will also be high. And when you are doing partial fine tuning, we are talking of again 10 to 30% of parameters that are being trained, and there is the cost is still moderate, as you see. But what changes is in terms of the newer way of doing training, this low rank adaptation and low rank adaptation. Now these are again partial fine tuning, but you are getting extremely high level of efficiency with very low parameters being fine tuned. So this is the new way of kind of doing otherwise as such. Okay, so we know that we have to fine tune. There is really no escape from that. Okay, but is there a reason when not to fine tune? You take an existing model out of the box, a very classic case like a Llama or Mistral or any of these open source or the Microsoft's the 5 series. They may be solving a lot of problem out of the box. So if that's the case, and when I say solving a problem out of the box, it means that I want to solve the problem using prompting techniques. So the first the first tests that are done on the LLMs are through the prompting techniques. So you use various kinds of prompting techniques to measure how well does the LLM perform with respect to my set of requirements. So if that works out, then I really don't have to fine tune. And there are a large number of use cases where, or lot of large adaptations right now, because of the complexity of doing fine tuning, people just adapt these out of the box, or they may even build what is this other solution called RAG, which is retrieval, augment, and generate, where the context, where the data which is not available within the model are stored externally and retrieved and then generated. So that's another way of escaping the fine tuning if you do not want to. So that's one of the reasons. Okay, you may mainly need facts and not general behavior. So in that case, we don't need. Data is small, noisy, and risky. Yeah, for which you really don't. And a frequent knowledge churn. That is another classic case where you want to not do a lot of fine tuning. And in a case like if there is frequent knowledge churn, then a lot of people adapt this other methodology called RAG, which is kind of a replacement for your fine tuning as such. Yeah, and the other side of it is if you fine tune and the cost doesn't really make sense for this requirement that you are looking at, then I don't think you would want to kind of do a fine tuning as such. But having said all this, I presume that today we can't escape fine tuning. You will eventually have to do fine tuning at some point in time to whatever use case. And I'll give you a very classic, use case where pretty much all corporate needs will eventually end up needing some kind of a fine tuning when we are dealing with real-time use cases for the use of LLM, because RAGs don't really solve that kind of problem out. So that's one use case there. Okay, now to do fine tuning, one of the bigger requirements is to collect to have very good quality data. So it's important that you collect the right data, and you have to clean it at a real good way. In the sense, one of the problems is if you have too much of duplicates, you are going to end up messing this whole fine tuning process. And then there are the other things which are pretty much part of the NLP stuff, where you have to tokenize it and do these pretty much the same split and things. See, eventually fine tuning is also transfer learning that you otherwise have experienced when you are doing image processing and things like that. So that's something that you kind of need to be aware of. So you'll go through this process of tokenizing and splitting, and then you would end up doing the whole training as such. So you will have to build a pipeline for this. So this is when you are doing a fine tuning, it is pretty much equivalent to training a model, just that you are not going through the full stretch of training. It's only a partial set of neural network that you are utilizing to do the training. Otherwise, it's a pretty much a training exercise that you have either developed using your classical ANNs and CNNs and RNNs. No different from that. It is here in this case, we are largely doing it for the NLP related training. So that's the only difference here. But otherwise, everything remains the same in terms of the processes that you adopted. Otherwise, trying to do either a machine learning or a deep learning algorithm. Okay, so you will notice today the yeah, I mean, one of the trends that you would start noticing is models need not become big, big and big in size, or it would not be that it will grow in size in terms of the parameters organizations or the larger companies that are building LLMs, you would notice that they are probably being of the same size, but qualitatively making it a big difference. Okay, so uh, one of the very important inputs is through this high quality data that's being given. So they use large language models to generate a lot of synthetic data in terms of qualitative equivalent to that of otherwise general data that you have. So this way, you are actually building in a very good set of models. The quality of the models is totally dependent on the data that you supply. So to give you an example, let's take you take a data set, and this data set has been and I'm talking of, let's say, do a pre-training, and you're doing a pre-training of this data set which contains the word apple, and it contains the word apple uh, in a reference to a fruit and in reference to an organization. Now let's take this and let's say this data set, which maybe let's take a 100-page or 200-page PDF or a text. Let's say that that particular word called apple, and much like when you read it, and you'll find that the sense of that document says the word apple there in that document is meaning more towards a fruit than towards the an organization. So if you take such kind of a text and train it, then what happens is you would get models there. At any point in time, if you put the word apple, it will only favor the fruit, or the next word it generates would be something more related with the fruit. Therefore, getting high quality data is important and balanced. So in today's scenario, the data that you are using um, is both positive and negative, in the sense, one, you should have balance of apple which references uh, let's say to a fruit, and it should also reference the organization, otherwise the models don't really come out well. And also when you say, hey, I need this, like, I mean, I'm talking in terms of a user requirement. I'll say I need this. You are also implying I don't need other things. Uh, so you want to also have statements of that nature within the text. So I mean, there are various ways they today look into text for kind of training these things. So when you have such kind of a balanced text, you really get good quality. Now, creating such kind of text is not that it's difficult to get from general sources. So you will have to build this bits synthetically, and that's how you're bringing in a lot of efficiency. Okay, so that's one side of the success, and then of course as you know, this is fine tuning is nothing but going through a very the exact use case of developing a model from scratch, either that you've done in a machine learning or a deep learning world. So you would evaluate the metric, you'll check for your regularization stuff, overfitting, underfitting, good fit, and you track this whole experiment over the time that you are kind of running. So these are all the key ingredients for getting success. not only for pre-training, uh, not only for fine-tuning, rather, I should be saying, but also for pre-training as well. Okay, now choosing the model, right? Organizations kind of get stuck into this problem. What kind of a model should I choose? Because here, the idea of fine tuning means that you're going to take an existing model and you adapt it for your own need, right? So it's easy for a lot of organizations that are not governed by a lot of rules. Like if you, I mean, a very classic case, if you take DeepSeek and you kind of ask questions with respect to Indian geography, I don't think it gives you information that you and me may like it. So it's very simple in that scenario. So outright you would say no to DeepSeek, and then you'll have to look at other models. So that way you will have to check your model. So one is qualitative checking. Then the other is, now the most important aspect of choosing the right model is the size, right? And choosing the size means the time. I mean, it's not about the time today, because of the overall inflow. That time is not a real a problem with respect to fine tuning. It's the cost of fine tuning, right? Can I do that in a $10,000 or $100,000, etc.? That becomes the budgeting. That budgeting becomes the issue. And then now we have another very classic problem here. Maybe you have developed your application to using OpenAI's models. Now, okay, I can't get the OpenAI model in the open source and for me to fine tune, right? Now, in that case, what happens? I have to fine tune the OpenAI models in their environment. So that's a proprietary LLM that you're using to fine tune it. Otherwise, we could, of course, there are plenty of open source that you can adapt to, and you'll have to you'll have to kind of look at what is the right choice of parameter size. Like now, if I'm sure you all utilize some way of 1 billion and 2 billion kind of parameters. You'll notice when you really want something to, let's say, reasoning kind of models. When I say reasoning here, let's say you want to solve a math problem, typical that you do in the econometric space and things like that, or any banking or an investment banker and all these organizations. Now, those models, if you've noticed, at a minimum, you want to get accurate result. They are all targeting at a minimum of 70 billion parameters. So there, yeah, you may have to use larger models. But on the another side of it, let's say you are just doing a classification for sentiment. I think anywhere between 1 billion to 7 billion parameter is a good choice to kind of solve it. So this is pretty much an exercise every organization goes through to find out what is that most appropriate stuff. And of course, I won't get into this idea of SLMs, which is small language models, and that is what gets into a lot of your mobiles and things like that. We are largely not talking of it for now, but maybe in another session that we will have a look at it. Okay, now fine tuning again requires its own set of tools, its own set of frameworks, and we should also know where you kind of deploy it. And I'm sure a lot of you all have used Olamas and deployed a lot of these LLMs within your laptops or desktops and things like that. Okay, so that's one side of it. Okay, now training, there are a lot of tools now. Hugging Face being one. Torch, the whole PyTorch's framework, like Torch, and there is this Onslaught, another set of tool for doing these fine tunings. And another very important parameter is you want to do distributed fine tuning. So then there are algorithms for that. The very classic tool of deep speed, which is the library that was used originally to train the first GPT, and they used it in that way. And there are various other tools like Accelerate and Colossal for fine tuning, for distributed fine tuning, and PyTorch itself comes with this inbuilt tools to do distributed fine tuning. Okay, and then you have your proprietary set of things. If you come from pretty much from a AWS space, SageMaker gives you that ability to do distributed fine tuning. And then as a part of it, you want to you need to pretty much record all the weights and biases. That's a very big task, and I'm sure if you use tools like MLflow, that would help you to track about it, because you need to know which weight and which bias gave you the best performance. So every experimentation, you need to record them so that you will clearly know which one gave the best. Okay, so that's the outside. And inferences, as you are aware of, there are various Olama and VLLM. That's another one. Hugging Face has own stuff, and NVIDIA also has own stuff for fine tuning and for kind of hosting it. Okay, so now deployment considerations. Again, there is a lot of things. First is, of course, going to be what inference engine that you will use. So if you are in the pretty much cloud environment like AWS or Azure and Google, they have their own environment where you can they give you the whole pipeline of build, experiment, and then deploy. So that's pretty much clear. But if you're in the open source world, then you will have to choose between various other like Olamas and VLLMs to kind of deploy. So that's generally, but a larger aspect people end up deploying in the cloud. But what is kind of becoming difficult to handle is the guardrails that needs to be added to these tools. Specifically, if you are in a corporate environment, you want to make sure that LLMs don't spit out any customer information. How do you control that? Right, you want to control on any toxic data that may be being thrown out. So these are things that you want to kind of add overall to it. And the other side is, how do you roll it out? And how do you do observability, which is a very big aspect, because the cost consideration comes from the whole observability that you kind of end up doing. Okay, so pretty much these are the frameworks and deployment strategies that you can actually use to deploy these LLMs, right? And maybe a lot of you are aware of these tools at this point in time. Okay, now evaluating. Now this is a very, very important aspect of fine-tuned LLMs. How would you evaluate them? Now there are two ways to evaluate it. You have qualitative and rather it should be quantitative ways to evaluate. Okay, so if it's all about quantitative way of evaluating, you would use tools like Blue and Rogue and BERT score to evaluate how the language quality has been. In terms of, when I say language quality, in terms of the next word that is being generated and things like that. And then if you're looking at task performance, then you're looking at accuracy and F1 score, precision and recall, etc., to get the qualitative output. And with respect to instructions, you're looking at an exact match or a human rating, things like that. If it's domain specific, then you're looking at the specific outputs of each of those prompts that you give to get the output as such. That aside, we also need to look at the safety precautions, which is a big problem today. Rather, not a big problem. It doesn't mean that the problem not exist, but yes, the sensitivity towards these are likely much more than it was been otherwise. So we need to add a lot of safety mechanisms, guardrails to have this. And then finally, you also want to make sure this is a very expensive platform to run, and you want to keep it as low in terms of everything, right? Be it latency itself and the processing cost, etc. So you want to kind of evaluate on all of these things when you, after you have fine-tuned your LLMs. Okay, and then coming to cost optimization. So there are again various methods. Some of the very classic cases that you notice here is the topmost would be in terms of small size model selection, and today we are going to use that fine-tuning method called PEFT, parameter efficient fine-tuning method. So that's one side. The other side is you're reducing this idea of quantization. Quantization simply means that if your floating point is of 8 digits, bring it down to 4 digits. So that's all it is about. So certain things would mean lesser accuracy because they are working in very small numbers in that kind of range. And then how do you bring in caching, how you can batch your things together. So that's another aspect of bringing in cost optimization. And then the context window size, right? So the larger the context window size, the more costlier it is, but it is more accurate in those kind of situations. As I said. So these are the other consideration. And then you also have these hybrid architectures, which is a very classic case that you use in edge computing, where you have a smaller LLM trying to gain as much as it can, and then connect back to the larger LLM if it can't solve the problem. So this you call a student-teacher kind of architecture, which is quite efficiently deployed. Like see today, I could take any small pre-trained LLM on code. Let's say you want to bring pre-train an LLM just for one particular language, maybe like Python or a Node, and then you want that LLM to have skill base as much as a 10 to 15-year experience, right? So all that you need to do is in those cases, one, the pre-train your LLM with generic code, like in GitHub, in the GitHub kind of scenario. Rather, you get GitHub Python code and then run it, and then take your own corporate code and then fine tune it. So that's one way you can bring in efficiency as much as that you can get in terms of accuracy, I should say. That's how. Okay, some of the common pitfalls and best practices. Yes, we have gone through it. Curate your data as much as possible. Use training techniques like LoRa and quantized LoRa, and deploy in a pretty much a canary mode for monitoring and latency. And what are the other things is fine tune when you're fine tuning when RAG would have solved the problem, right? And deploying without controls for like PII specifically corporate things, okay? And you are ignoring your cost. That is that. Okay. Okay, so if you want to try some pre-training, what would be the choice of models that you want to use? There are many models available, but some models are very specific for training requirements, like this tool called GPT Neo from the Eleuthер AI, or Tiny Llama, which is another one that can be. These are both experimental and testing for your things. Okay, and then you have Digital GPT. You have something from Meta, Mosaic ML, which is nothing but data breaks. So if you look at them, these models, some are good for text generation, summarization, uh, or quick experimentation. And if you want to try some classification, etc., then this is the model that you want to do. And if you want to see some production-friendly inferences, these. While Tiny Llama, which is a very good model, which is a very modern architecture, it resembles the llama, and that's why it's also named as Tiny Llama, and this is very specifically used in a lot of colleges for your learning and experimentation as such. So these are the small set of models, but you could take anything, including Microsoft's Phi and stuff as where these are just very specifically targeted towards your learning and experimentation. Okay, and now how do you want to start it? See, everybody wants to learn fine tuning, and as I repeat here, fine tuning is nothing but the typical training that you have done otherwise with a machine learning or a deep learning model to get to its level to its stage. Okay, so that being the case, you have to look into that. But again, there is complexity associated with fine tuning. So don't try to do everything in one go. Take one of those models and then target towards, let's say, maybe a summarization or a classification or something, instruction. So don't try to do everything in one go. While if you take larger models, that you take any of these open source, any of these meta models, it actually does all of this: summarization, classification, and Q&A, including for multimodal. Right? We've been largely talking of text that does even multimodal. Right? So it's a little complex to start then, but if you can take anything very specific, my take would always be choose a summarization and a text classification in one of those models. You can pretty much run this in a collab environment that Google gives you actually free. You don't even have to take a paid environment. Or if you have a laptop with GPU, excellent. It also solves the problem. Okay, so I just want to give you a final slide in this of how a very specific LLM that was built. I'm sure you might have heard about this, the Bloomberg's GPT. And why did Bloomberg do that? Topmost reason that they couldn't share a lot of that data that they have been using with anybody else, right? So they used their own financial data sets, news items around that, and then they built a 50 billion parameter GPT style transformer. And which is what now I'm sure they would be. Now, if you take this use case, they have built this general. I'm sure that they would be fine tuning now for very specific use case, maybe investment banking or general banking or various other crypto, maybe. But they have a model of their own and how they built it up because they couldn't share a lot of this data. And they would, as I said, they would also be fine tuning. and output of that is this LLM, which they can very specific targeted towards finance. Okay, likewise, trying to build something purely for medical, I think nobody is really able to come up with that model, largely because of the PII data, and it's not easy to get data for that. And you need large data if you want to build up a LLM. So it cannot be done with small set of data. Okay, so that's the use case that I wanted to kind of share on how. Otherwise, yep, that's all from my end.
Thank you so much, Mrs. Chandran, for such an insightful and engaging sessions. Now, participants, if you have any questions, please drop them in the question box so our expert can answer them. We will wait for 2 to 3 minutes to understand if any one of you have questions so far. If not, we will move on. Over to you, Mr. Chandran.
Yep, finally, that's all from my end. Otherwise, yeah, if there are any queries, I can take up in the chat. Okay, otherwise, I think we don't have any queries. Probably we can wind up then. So thank you all for attending.
Yeah, thank you, Mr. Chandran. Now, if today's discussion inspired you to dive deeper into LMS and fine tuning, I encourage you to check out our virtual instructor led training programs on springpeople.com. These programs are live and interactive, led by certified trainers, and you can attend them from the comfort of your home. If the listed batches don't fit your schedule, we can arrange private group sessions or recommend flexible self-paced learning options. For details, you can just drop us a note at training at springpeople.com or call the number you can see on your screen. We'd love to help you take the next step. Now that was a great session. And to everyone here, thank you for giving us your time and energy today. Your participation really means a lot. We'll be sending the recording of this session to your registered email shortly, so please keep an eye on your inbox. And please do share your feedback so we can improve our future sessions as well. Until we meet again, keep learning, keep experimenting, and we look forward to seeing you at another Spring People session. Take care and have a wonderful day.